has to prepare for this. Tripping in the world could be dangerous.
Well, hi everybody. Here we're going to go over what we use to make our car info, entertainment, and control system SIDEX.
Our main tools were Kivy frameworks, a strong RTOS knowledge, embedded Linux knowledge, Arduino programming, and Python libraries.
At the beginning, when the project was presented, we started defining a clear vision of what we wanted to achieve. We have had a clear vision of what we want. Since the beginning, we drafted the views of the main interface and started listing all the functions we wanted to have.
We started developing the graphic interface using Kivy, and after a few weeks going through documentation of Kivy and generate layouts, we went from a simple Hello World program to a complete graphic interface with multiple screens, just like what we will see here. Reaching this point, we wanted to see if we could bring together the graphic control and the hardware control. So we implemented code that shows us in the interface the ambient temperature using the DHT11 sensor and its own library, and the general port input-output library.
After we designed the whole front end, the hardware team explored how to use the Raspberry Pi to reproduce audio with it, while the software team focused on how to read MP3 files from an SD card and how to handle the reproduction of such files. In software terms, we wanted to keep the system as modular as possible. This allowed us to break down a complex card system into several trivial tasks. Thus, to read the MP3 files in an SD card, we created a Python module named USB Songs that, along with OS and subprocess libraries, allows us to detect the presence of an SD card in the Raspberry Pi, and also allows us to store the directories of every single MP3 file in the SD card, as well as the names of such MP3 files. Once we had all the names and directories of the MP3 files, we used 5 dynamic Kivy buttons in order to create a scrolling menu where the user can select any song he wants from the SD card. And to control the audio reproduction, we created a Python module named PlayMP3, which has an MP3 player class that, using Pygame Mixer library, handles all the play, pause, forward, and rewind functions. Bringing together the list of MP3 directories and the MP3 player class, we were able to create reproduction queues that start from the song chosen by the user and move all the way forward. And to generate the automatic reproduction, we used Kivy Clock in order to create a task that is constantly checking if the current song has already ended. And if that's the case, the system automatically moves forward. This ability to use Kivy Clock also allowed us to create tasks that constantly update the temperature and check if the SD card is still connected.
Once we achieved this, we tried to use the jack connector to reproduce audio, but the game wasn't big enough to be heard in the car. That's why we decided to use the chip Max 983578A to reproduce audio with the ports of the Raspberry Pi and a speaker using the protocol I2S. This chip is cataloged as a Class D amplifier, so using it, we were able to reproduce the files from the SD card to the Raspberry Pi ports, amplifying the signal 15 decibels. Last but not least, and in order to make a fine prototype, we developed a complete car luxury design using the microcontroller Arduino Mega. We control the Arduino with the Raspberry Pi by sending bits to the Arduino ports, clearly using pull-down resistors, avoiding high impedance. The luxuries are things such as a sunroof using a servo motor, the control of the front lights using PWM ports, the collision alarm using an ultrasonic sensor and a buzzer, the emergency lights, and the turn signals. But with many tasks to control and a linear program, we couldn't make it work as smoothly as we wanted. That's why we used FreeRTOS. Taking advantage of the capabilities of this kernel, we use concepts like creating tasks with time delays or taking and giving semaphores to control the backlights. But we still wanted to make the finest prototype possible. So that's why we designed and print a 3D scale car to implement all the car luxuries we designed. Finally, we use a relay to turn on the Arduino when the interface is running, in order to avoid power loss when the car is off.
This is the final block diagram.